In this video, we will explore liquid-liquid phase separation of polymers in aqueous solutions, as well as the sensitivity of liquid-liquid phase separation to ion-specific effects. The polymer used for today's experiment is polyethylene glycol, also known as PEG. PEG is available at any grocery store or even on Amazon for less than $20. So here you can see that when I add water to PEG and I stir the solution, PEG does dissolve in water, giving us a homogeneous mixture. Water and PEG are both polar molecules, and as we know that like dissolves like, PEG dissolves in water. Hydrogen bonds hold PEG and water molecules together. Now when I heat this PEG solution, it starts to boil, but there is no other visible change. Boring, huh? Let's see what happens if we add salt to this solution. Adding salts can cause PEG molecules to come together in a collapsed state, or we can simply say that they clump together, forming two separate phases. This is salting out. On the other hand, adding salt can promote the extended state of the polymer molecules, due to which there is no phase separation. This is salting in. In 1888, Franz Hofmeister ranked the salt ions based on their ability to salt out or salt in polymers. The ions on the left of the series have a strong salting out effect than the ones on the right. Hence, sulfate, which is to the left of the series, will have a strong salting out effect compared to acetate, which is to the right of sulfate in the series. Let's see what happens if I add sodium sulfate to PEG solution. I have 2 ml of PEG solution to which I am adding 2 ml of 2 molar sodium sulfate solution. You can see that the phases separate right away. Let me add a drop of food color to the test tube and stir up the solution. You can now see the two separated phases distinctly. Phase separation took place at room temperature. Now, before we try another salt, we need to know the term cloud point temperature. It is the temperature at which the solution turns cloudy as the polymer molecules start coming closer together. This is when the two phases start to separate. In this test tube, I have a homogeneous mixture of 2 ml PEG solution and 2 ml of 4 molar sodium acetate solution. You can see that the phases have not separated and this mixture is at 30 degrees Celsius. I will heat this mixture in a water bath and wait to look for the cloud point temperature. That's when the phases start to separate. There you go, that's it. The solution is turning cloudy. In the test tube here, I have a solution of PEG and sodium acetate, but this time I added a drop of red color, so you will be able to see the two distinct phases. Look at the cloud being formed there and the two distinct phases. Enjoy!